Hi guys, welcome to my YouTube channel. Today we'll be talking about work energy and power. Work energy and power. So this is a new topic that we'll be treating today. So let's get started. Introduction. So this topic explains how force causes energy and transfer, how force causes energy transfer, and how we measure the ability of an object to do work. So this topic, because we are treating work, energy and power, we'll be having much understanding on how force causes energy transfer and how we measure the ability of object to do work. So in physics, work, energy and power are closely related. They describe how motion change when a force acts. So they describe how motion change when a force acts. So we will now take this one by one. So start with work. So what do you understand by work? So work or work done. So work is done when a force causes a displacement in the direction of the force. Note, a force causes a displacement and it must be in the direction of that force. So now that's when we can consider that there is work done, because when the work is being done, it must be in the direction of that force. But let's take note so we won't get confused. So W, which is our work done, is equals to force times distance cos theta. This cos theta is there, but we don't write it actually because maybe the question we are doing then is theta of 0. So when theta is 0 and cos 0 is equals to 1, so they just said work is equals to force times distance, ignoring this. So but this is part of the formula in case if you are given at an angle, if the force acting is at an angle. So that's work is equals to force times distance, where the W is equals to the work done, note in joule, because the SI unit of work done is joule. F is the applied force and S is the displacement in meter, and theta, which is the angle between the force and the displacement. So that's when the force is being acting at a particular angle. So now we'll talk about type of work. Well, we have positive work. So instead, when the force or the displacement are in the same direction, they are in the same direction. So e.g. you pushing a cart. So now when I said it must be in the direction of the force, so it must not be that in the same direction, but it must act in the direction of it. So now let's see when it is positive work. That means they will be in the same direction, not oppositing each other. So e.g. pushing a moving cart. So the cart is already moving, then you are pushing it. So that means they are moving together. So pushing a moving cart is a positive work. To the second one, we have negative work, which is when the force opposes the displacement. So that means they are in opposite direction. E.g. friction. Friction will always opposes a body motion, because when the body is moving this side, friction will be moving the other side. So that's why they call it a resistance to against the motion, or it opposes the motion. So to the next type of work we have zero work. So when the force is perpendicular to the displacement, this is when the force is perpendicular to the displacement. An example of this kind of zero force is a centripetal force in a circular motion. So centripetal force in a circular motion. When I talk about circular motion, that means is in circle. The kind of motion in circle. So and in that motion we have a force called centripetal force. Even there are two types of force in that area. We'll later talk about that in the next previous video, in the next coming video. So when we talk about the centripetal and the centrifugal force, okay. So that an example of this zero work is centripetal force in the circular motion. Now we'll move to energy. So energy is the ability to do work. So the SI unit of energy is joule. So it's similar to that of work done, having the SI unit to also be in joule. And we have types of energy. We have the mechanical energy, the chemical energy, and electrical energy, and so on. So this is not limited to this actually. So we have other type of energy also. But here we are concerned with we have to talk about more about mechanical energy. So that's why I said, but here we want to talk more about mechanical energy. So now type of mechanical energy, we have what? The potential energy and the kinetic energy. The potential energy is the energy is the stored energy an object has due to its position or its state or its configuration. So it's the energy an object or a body has due to its what? Position, its state or its configuration. It's the energy an object possesses that can be converted into kinetic energy when the object situation changes. Meaning that if the object is staying static, it's having that potential energy there. But when it changes, it can be converted into a kinetic energy. You see, moving down from a potential energy to a kinetic energy. And it has a formula. It has formula. Obviously, the formula is equals to mgh. So m is what? The mass, h is the height, and g is acceleration due to gravity. So the other type of energy we want to talk about is other type of mechanical energy we want to talk about. Please let's note that type of mechanical energy. The other type is kinetic energy. Kinetic energy. And is energy possessed due to motion. Is the energy an object possessed due to its motion. Please let's get that right. Is the energy an object possessed due to its motion. So it is the energy an object has when it is moving or in action. So when this pen is moving now, the energy it possesses when it is moving or when it is in action is what we refer to as the kinetic energy. E.g., a rolling ball, a guitar string vibrating, you can see. So when they are in motion, so the energy possessed is referred to as kinetic energy. We have the Ke is equals to, which is kinetic energy equals to 1/2mv square, where m is the mass of the object and v is the velocity of the object. Okay, so that's the formula for calculating kinetic energy 1/2mv square.